This is just a quick, poorly edited video to show how I mounted a Vevor X-axis power feed to my round column mill. These power feeds are made for full-sized bridge ports, and they do require some modification to adapt to a round column mill. When I'm considering a project like this, I usually go to YouTube to see how others have done it, and I didn't see a whole lot out there on this topic specifically, so thought this video might be helpful to someone. By the way, I am not a skilled machinist and just a hobby guy, so forgive my skill level, but I hope this is helpful to someone. Enjoy. So first of all, I mounted mine on the right, this motor on the right. It just works a lot better for me to have this on the right. I'm very much right-handed, and I like to have the controls here on the right. This is working great. By the way, this is not a Vevor review, but I do have this from Vevor. I also have a mag drill from Vevor, and a couple other things that I gotta say for the price and the obviously the location of that we know they're all built. They're pretty decent, and certainly for the money they seem to be decent. So I really can't complain about their products, and I probably won't hesitate to buy something else from them in the future if the right thing comes along. But anyway, mounted this one on the right. The problem with mounting on the right is all of the bearings, at least on my, I suppose a lot of these mills are different, but at least on this sort of Enco Rangfu version, all the bearings for pushing the table back and forth as the lead screw moves are mounted in this end, so you have to deal with all those bearings. It would have been easier to put the motor on this side, on the left, but the controls would have had to have been on the back, I think. It just wouldn't really have worked well for me. So that's the first thing, is where to mount. Now let me show you the mount. All right, so this is how the setup usually goes on the end of the mill, on the right side of this mill anyway. Again, different models I'm sure are different, but this is the end cap, I don't know, bearing block, I guess you'd call it. There's a bearing in here that goes against the table. There's a bearing in here that goes against the hand wheel, essentially. There are these roller bearings, thrust bearings, I guess. They each have a race on each side. I lost one of those, so it's missing. There should be another one in there. But anyway, this is this goes on. This cap goes on here and is pinned with a roll pin here, and then after that, the hand wheel goes on and locks in there with a little set screw. So every time the lead screw turns, it's pulling against this pin, pulling or pushing against this pin that's locked through the shaft, through the lead screw, and that is either pushing the table this way against this bearing, or it's pushing would be against this bearing and then pulling against this bearing. So one way or another, you had a bearing on either side, and as the lead screw pulls in and out, it pushes the table in and out with it. So that's the way that works. There's no bearings on the left side of my table anyway. They were all on the right, so I had to accommodate for that in this modification. Okay, so this is the mounting bracket that comes with the Vevor. I guess this is the same looking design as every one of these X-axis feeds that I see, even the really expensive ones. But there's no place this thing's going on that table. It's just way too big for anything that you could do with this mill. So I made this mounting plate, and you'll see it has similar design to this guy. It's got the same mounting holes that hold the plate to the table. It's got roll pins for holding the mill in the right, the motor in the right orientation. This one from Vevor also had pins horizontally here at 3 and 9. And I just rearranged that a little bit and drilled them out bigger so that they worked better on my setup. And then these two threaded holes here are for the actual cap screws that hold the the motor to this plate once it gets put on there. Now, to solve for the bearings, this is probably the hardest part of installing this thing, is figuring out how thick these bearings need to be. That took me a lot of, boy, I'll tell you, put that motor on and took it off about 100 times probably, just testing different thicknesses until it seems to feel right and sound right. And it sounds like it feels like the table is being pushed by the bearings and not the gear on the motor. You can feel it and hear it when you play around with it. But if you get it right, eventually you don't hear the gear when you're turning it with the hand wheel. You just feel the smooth motion of the bearings pushing the table. So for this one, what I had to do is I used one of the old bearings, and I had to buy some smaller thrust washers, because the two of these were just too thick, two of the originals from the original mill. So I got these, what are they, 4x8 millimeter or something like that. I bought a pack of like 20 off of Amazon for about $5, but they're kind of a different style. They're not a ball, they're a roller needle, I guess you call it. But anyway, these are all gooped up with grease. But this is then this spacer goes over the shaft to fit the OD fits inside the motor, the bearings that come on the motor, and the inside it fits the shaft. There's a sleeve like this that comes, I guess it's actually a bearing race that comes with the motor when you get it, but it does not fit the lead screw for this mill, so had to modify that. Okay, so here's the assembly. This guy goes on here. These are the original cap screws that held on the first plate, the plate that came with it. So we get this guy on. That's just a piece of 1/2-inch steel, by the way. And if anybody ever wanted them, I could give you the dimensions of this hole. I don't remember them off the top of my head, but I can give you all those dimensions. Okay, that goes on. I'll tighten that down. Then this, in my case, this original bearing goes on. That goes right through. That's a clearance hole for all of that. I had to add another shim there. This is the sleeve that I made up, and then another one of these thrust washers, thrust bearings, I guess you call it. Oh, that goes on after the mill. Sorry. Okay, so I just got to tighten these down. Okay. Now, you can pick your orientation, obviously. You could turn this, you could have the mill straight down, then it would hit the table sooner, so you'd have less travel. I rotated it up just like this. It's just enough. It's just enough to clear the table underneath, but also not stick up and interfere too much if you had a long piece on the table. This handle sticks up, so that would interfere, but you know, I haven't seen a problem with it yet. All right, so this guy is just hanging on those roll pins right now. Then we put in these cap screws. Just cinch it in here. Okay. Good. Now, put this bearing in. By the way, I've got this pretty well all greased up. It's pretty slathered up. This comes with some kind of red tacky grease. It's super sticky stuff. I cleaned that all out and took it off because I don't know what it is, but I also just, as I was working with this, I had to drill some of these holes out and a lot of measuring and fitting, and I didn't want that goop all over everything while I was doing it. So I cleaned that all out, and then I just put some regular grease in here. And then on goes the gear. Now let me talk about that. So this is the gear that drive gear, drive wheel, whatever, cog, whatever you want to call it, that comes with the Vevor mill. It's made of something brass looking, but it's not brass, I don't think, but I don't know what kind of voodoo material it is. It mills sort of like brass. It crumbles off in like a fine powder. But anyway, whatever it is, it's very easy to modify if you need to. So I had to do a bunch of things to make this work. So one, first of all, I had to turn this through hole out to a larger diameter. I think it's 687 thousandths is, I don't know what that is in millimeters, but that's what the lead screw is. And this was quite a bit smaller, which is funny to me. I don't have a Bridgeport and I don't have any experience with them. It's funny to me that a Bridgeport would have a smaller lead screw than these round column mills, but apparently they do. So I had to bore that out. You'll notice there is a keyway broached in there, which I've almost eliminated by grooving this out, so I don't use that. And then after boring that out, I had to turn this face off. This protrudes a little bit more than, if I can point better. So it's this surface here. You probably can't see, but it protrudes from the main face down here. And so I had to turn that down to get it to fit right with the way that I had the bearings set up, and all the shims and washers and things. That might not have been necessary if you did the bearings differently. I don't know. On the top, I had to shorten this quite a bit because there isn't enough shaft left to get the wheel on. So I had to turn this, or take the end of this off quite a bit. Rather than using a keyway, I don't have a broach, so I didn't want to deal with a new keyway, and there's no keyway in the round column mill. They used a roll pin, so I drilled this out to use the same hole that had a roll pin in. I've since decided to use a cap screw through there that just fits perfectly rather than a roll pin, because lately I've been taking it on and off so often that I didn't want to have to deal with the roll pin. But that seems to work fine. It fits nice and tight. So I put a cap screw through here, turned this down, and then had to turn this, I forget what you call these, but you know, this is the mount for the original mount, and that meshes with the hand wheel. So had to turn something similar out of this one. I just did that on a rotary table. I wasn't sure how I was going to do it. Maybe it's a common thing that people know about. I don't know. But I took a 3/8 end mill, put this on a rotary table, and this is just offset, just one side of center, and comes straight through with the 3/8 end mill. And then you turn it 120 degrees, and you come through with an end mill again, turn it 120 degrees one more time, come through with an end mill again. And that's what you end up with. So that worked out pretty well. Probably took me 3 days of thinking how to figure out how to do it, but it was pretty easy in the end. So this part is pretty heavily modified. All right, so this guy goes on. As I mentioned, I have stopped using the roll pin. I'm now using a cap screw here. However you want to do it, I guess. As long as it holds it in place. And some of this can be a little fidgety at times. So you have to get the orientation of this just right. Might be this way. Yeah, maybe, I think so. Yeah. So now this is, I didn't thread the other side of this brass piece, but it just sort of self-threaded. It's so soft. And the cap screw kind of threads in there. If that doesn't hold up, I'll put a roll pin in it someday. But for now, it's nice and tight. It doesn't wobble. There's no slop in it at all. So that's on there. And then the last thing is the hand wheel goes back on. And there's just enough shaft. Again, you got to modify that. You got to cut that brass piece down quite a bit, so that there's room for the hand wheel. I did not want to lose the hand wheel on the right because I use the right hand wheel fairly often. And there you have it. And I think that's about it to say about that. So let's talk about, all right, first let's talk about how I have this DRRO slide mounted. Again, I don't know if this is the right way. It works. It seems to be very accurate and it's been working well for I don't know, I've had it on there maybe a year. So I guess it works. It's good enough. But anyway, I mounted it directly into the track on the front of the table. Got some pieces in there and then it screws in through the front with some cap screws. And then I've got a little spacer behind there. I don't even remember why I did that, but for some reason I thought it needed to be spaced. So that's how the slide itself is mounted. And then if we come underneath down here, this might be hard to see. I can't really show it very well, but the reader for the slide is here, and it's mounted to a piece of aluminum angle here that's bolted in through the front of the table. And again, that's been working very well. So what I did is I mounted the auto stop switch. This is the switch. You can push that either way, and this is just a cap that goes on top of it. It's loose, but it's loose, but it hits the buttons when you push it. So what I did is I mounted that to a piece of angle. I had to make this up because the bracket that comes with it doesn't work. So I mounted that to a piece of angle, to another piece of angle going the other way in here, and used the same screws that hold the angle plate for the reader. So you got these two screws down here holding both brackets, and it is solid as could be. Okay, now these are the adjustable stops they give you to push the automatic stop buttons, and these are meant to go in the track also, but the problem is they don't stick out far enough to get past my DRRO reader or slide. So I had to make some new brackets. That's what these are here. And then these are the original plungers, I guess, and springs that come in the Vevor package. I took them out of these holders, and so it made up this angle bracket, and then this tube is drilled out to accept the plunger and the spring, and then I just milled a little slot in it here. Here's a view of the stop actually working. And you can see leaves plenty of room. This is my other Y-axis DRRO slide under there, so I have to leave a little bit of room. That works. Okay, the only other thing I had to modify, this is the original gib screw for the X-axis gib adjustment, and when these are threaded all the way in, they barely clear the DRRO slide, so they weren't working that great anyway. And if they're up when they're screwed in, they now will get hit by the plunger for the auto stop. So it was time to get rid of those, and all I did here was I took these out and mounted up a bolt with a wing nut. Here's the version of it out. So this is the original adjuster, and then I just got, these are 5/16 18, or they're probably whatever the metric equivalent is, but 5/16 18 threads in, and then just welded a little wing nut on the end of that. And this is 3 inches long. This is a 3-inch long bolt, so it gets you way out beyond the stops and the DRRO. So this, I think, is a better solution than what I had. And when it's way out here, you really don't need, these have this fancy spring-loaded option so you can pull it out and adjust it. You really just don't, I just don't need that. So this wing nut, I think, is going to work fine. So we'll see in time. Just a couple other things. What I did lose over here is, well, let me show you the original. I did lose my increments for the X-axis, the dial. So what I'm going to do is I'm going to mill or turn another, not mill, but turn on the lathe, a new big dial, 3-inch dial that will slide over here, and I'll put a mark on the top here, and I'll put my increments on that. So I've got to make a dial. Probably going to follow Mr. Pete's version of that on YouTube. but I think that'll work. So that'll take a little bit of time. The only other thing I'll say is I've seen reviews of these motors before, and people complain that they move too slow. I don't find that. If I turn this on just a little bit, I mean, you can move this thing really slow. I don't know what speed that is. And the little bit that I have used it seems to be plenty of torque to plow through steel with an end mill. And then on the fast side, you know, it goes pretty quick. It's as fast as I would crank it by hand, I guess. And if you hit the express button here, it's even faster. So it still takes a while to get where you're going, but you know, overall it works pretty well. So I don't have any complaints. I would say it's a heavy unit too. I don't know what, you know, what's in there for a motor, but it weighs a lot, quite a lot. So I don't know, it feels solid, seems to run really smooth and work well. Can't complain. That's pretty decent. I also forget what I paid for this, but I think it was less than $200. I think it was like $160 or something like that. So, you know, I don't know. The ones that are made for the round column mills that sit flat and go over here, I think you can get those off of AliExpress or something for $300 or something now, which isn't bad too. That might be a good option, but I just happened to see this one and it seemed like a very, very reasonable price. And I've been decently surprised by Vevor's quality. So it's pretty good. So that's about it. I hope that is helpful to somebody, and thanks for watching.